Good morning, class. We are looking at Chapter 6, Application of Integration, and we've covered the first part. Now we're going to cover from section 6.2 to 6.3. 6.2 volume, the method of disk, 6.3 volumes by cylindrical shell. So the disk method, first, let's remind everybody as far as the area of a curve is concerned is the summation of an infinite number of rectangles. The limit, as n goes to infinity, of summation of I from 1 to n of f of x of I delta x, where delta x is b minus a over n, x of I is a plus I delta x. We remember that. If we take this rectangle and revolve it about a line, for example, the x-axis, it creates a disk. We remember the volume of a cylindrical shape is pi r squared h. And note, this disk is nothing more than a cylinder on its side. So it's a cylindrical shape. This is the height. Which is the radius, we call the radius. This thickness, or in this case, the width, or dx. And so this is the r, pi r squared h. You can see that this is the r or h. And the width is dx, the width, this width, okay, or this one if you will. So pi r squared h. If we sum up an infinite number of cylinders, we have the new integration formula. The volume is the integral of a to b pi r squared dx. And this equation is for a horizontal axis of revolution. Now, bear in mind that r in this case would be the function y or f of x. Y or f of x. So, volume of a disk, a slice of disk, is area of the slice times its thickness. And area follows a circular shape, therefore pi r squared times dh. And I'm going to use dh because if we move along the x-axis, dh becomes dx. If we move along the y-axis, dh becomes dy. So you can pay attention to the concept that way. Sum up an infinite number of disks. As the slices get infinitely thin, the volume becomes the limit as n goes to infinity of summation of a of x of I delta x, the integral of a to b a of x dx. Now, r is h, distance from the axis of rotation, width in this case is dx, and rotation about the x-axis, and then you have to move it along the x-axis, gives the formula v equals the integral of a to b of x dx, or pi r squared dx, and pi, the integral of y squared dx, y or f of x, remember that, or a of x if you. Now, rotation about the y-axis, we are going to write the integral of c to d. We don't want to use the same a and b, although we can, but c to d a of y dy, integral of pi r squared dy, where in this case the r would be x. So what do I write? I like to write dv, which is an increment of the volume. This disk is an increment of the volume. A, the area, times dH. The area of the disk, which is pi r squared, times dH. And so what do you need to figure out? What is R and what is dH? That's what you need to figure out. Now, if we happen to have a hole in between, we end up with dV is pi r out squared minus r in squared dH. We will discuss that with examples. It's a method called the washer method. And so in short, the volume is the integral of a to b dV, a to b a of x dx, or a of y dy, depending upon how we do the revolve. So this equation is for a horizontal axis of revolution. A of x is the area of a moving cross-section obtained by slicing through x perpendicular to the x-axis or the axis of revolution. We're looking at this and this concept, perpendicular to the x-axis. So I want to pay attention to that concept. Let's look at a simple example to see how we tackle this. We want to find the volume of a solid of revolution generated by rotating about the x-axis, the region under the graph of y equals e to the power of x from x to equals -1 to x equals 2. It is extremely important to number one graph. So here's y equals e to the power of x. This is 0, 1. And we are going to go from -1 to +2. So that means this region, if we were to shade this region, this is the region that is going to be rotated about the x-axis. So this is the region. So what happens? Here's an increment. We pick a line which has some thickness. We're going to revolve this about the x-axis this way. It creates this disk, ultimately looking like this when the whole thing is rotated almost like a cone. This is the height. So we are looking at ADH, pi r squared dH. So we got to figure out the r. The radius is this. The y-axis or f of x. And the thickness is dx. So r or y or f of x, we are going to write e to the power of x. dv is pi r, which is y squared dx. So y is e to the power of x. When we square it, becomes e to the power of x to the second power or e to the power of 2x. So the volume is the integral of this from -1 to +2. Now, of course, this is e to the power of 2x, and we are going to remember, if we are differentiating, we multiply by 2. We are integrating, we divide by 2. So pi divided by 2 e to the power of 2x from -1 to 2. So everything else is elementary. We've seen integration. E to the power of 2x, you plug in 2, and then you plug in -1. When you plug in 2, you get e to the power of 4. When you plug in -1, you get e to the power of -2. This is the precise answer. Of course, this can be written as 1 over e squared. Now, if you use a calculator with a bunch of decimals, you get 85.55. But bear in mind, this is the exact answer. You must always write the exact answer. You can also tag along approximation if they ask you. Determine the volume of a cone with a height of 15 feet at its center and a circular base with a radius of 8 feet. Now, we are going to use this concept of a rotation. So hint, rotate a line about the x-axis. And everybody remembers the shape of a cone. So let me just looking like that. That's the shape of a cone. So here's what we do. We start with this line that goes through the origin. We want the radius to be 8 feet. We want the height to be 15 feet. By the way, you can do that in a different manner. You can make this one standing up along the y-axis, makes no difference. This is along the x-axis. So we have this pair 0, 0. We have this pair 15, 8. And now that we have the two pairs, we can come up with the equation of a line, because all you have to do, calculate the slope. So 8 minus 0, 15 minus 0, it's 8 over 15. And we have 0, 0, so we use y equals mx plus b, where b is 0 and m is 8 over 15. So it gives us this equation. All right, I need the space. So here's an increment, a thick rectangular shape. And that creates, when we do the revolving about the x-axis, creates this disk, an increment of the volume, where we use dV is ADH. So the area of this would be pi r squared. So it creates this shape. This is a disk with some thickness. And the whole thing, when you revolve it, becomes this cone. So we have this distance, y or f of x, which is 8 over 15x. And the thickness is the x. So pi y squared, the y coordinate of this point. The y coordinate of this point gives us this r equals f of x or y coordinate, which is 8 over 15x. And we are going to move this along the x-axis from here to here. That means from 0 to 15. So pi times this 8 over 15x quantity squared times dx from 0 to 15. Now it's a simple case of an integration. So we have a pi, we square the 8, 64, 15 gives us 225. We can keep this one out as 64 pi over 225. As a typo. And then we have the plug in 15, 0 gives you 0. So 15 cubed, when we do the math, we end up with 320 pi cubic feet, which is an exact answer. Now, I want to remind you of the volume of a cone, which was in the form of 1/3 pi r squared h. So 1/3 pi r is 8 squared. H is 15, and that gives us 320 pi cubic feet. We get exactly the same answer as we were supposed to. Now, the region bounded by y equals x squared, y equals 0, and x equals 2 is revolved about the line x equals 3. We want to find the volume. Again, we start with the graph of y equals x squared. And notice this is y equals x squared. Y equals 0 is the x-axis. And x equals 2. So we are talking about this region. This is the region. And we are going to revolve it about x equals 3, this line. We're going to revolve it about this line. So let's see what happens. So as we do the revolving, there is this cylindrical shape created in the middle. This distance is x. We are revolving it about x equals 3. So this distance is referred as to RO. That means R out, which is 3 minus x. This is known as R in. As you know, this distance is fixed at 1. So R in is 3 minus 2 or 1. This is 3. This is 2. That's why we have this distance of 1. So look at this disk now. Remember, we are revolving about the x-axis, the x equals 3, which is parallel to the y-axis. It's just revolving in essence along the y-axis in the same concept. And so if you look at this disk, then in the middle is empty. That's why it's called the method of Washer, and it follows dV equals pi times R out squared minus R in squared times dH. Now this disk goes up and down. So dH is dy. So R out and then R in. So just plug in. Now, because it's going up and down and dH is dy, everything must be a function of y. So this R in is a fixed number. We don't have to worry about it, but this is 3 minus x. And x comes from the curve. So 3 minus square root of y. So if we use a horizontal slice, the disk now has a hole in it, making it a washer. The volume of a washer is pi times the parentheses r out squared minus r in squared. So the area of the bigger circle minus the area of the inner one, the smaller one. That's why pi r out squared minus pi r in squared. We factored out the pi. So the area of the bigger one, the bigger circle, minus the area of the smaller circle. That's what this is all about. That's what this area becomes. And so r out, which is 3 minus x, the x is replaced with square root of y because this one, by the way, x is plus minus square root of y. This side of it is positive, this side of it is minus square root of y. And so now all you have to do, plug it into this formula. You're going to come up with the dv. So pi times r out, squared r out is this whole thing, minus r in. R in is just 1 squared. And dh, we said this disk is going up and down. dh is dy. Okay, so this is r in. And therefore, pay attention to this one. R out is 3 minus square root of y, and r in is 1. So we have it like so. And because we are going to go up and down, take a look at this pair having coordinates 2, 4, but we're going to go from 0 to 4, the y coordinate. So 0 to 4. And pi, you can keep it in or out. It doesn't make any difference. It's a coefficient. Now, we are going to square this. Now, the rest becomes a simple case of integration. But getting here, all the explanation, the graphing and everything is to show how we arrive at this one. This is the hardest part. And I can't believe it can be done without the graph and without the slides that we have here to show exactly how we arrive at it. And so this one gives you 9 minus 2 times the first times the second one minus 6 square root of y plus square this one becomes y, and this one minus 1 square this one. So I'm assuming nobody has any problem with elementary algebra. We're going to change this to y to the power of 1/2, and then 9 and negative 1, they add up to 8. So we have 8 minus 6y to the power of 1/2 plus y dy. 8 gives you 8y. This gives you minus 6 over 1 plus 1/2 y to the power of 3/2. This gives you 1/2 y squared from 0 to 4. And we have the pi. I'm showing you the integration steps. And so this is 3/2. So minus 6 divided by 3/2 or times 2/3, and it becomes minus 4. So this whole thing becomes minus 4, 12 divided by 3. I'm assuming nobody has any problem with that. Now, you plug in 4, you evaluate it, and you plug in 0. Of course, 0 gives you 0, you don't have to worry about it. But if you plug in 4, 8 times 4 is 32. 4, it means square root of 4 cubed, 2 cubed. 8 times 4 is 32, so minus 32. And then plus half of y squared, half of 4 squared, or 16 is 8. So the answer is 8, and then times pi as the final answer. So that should be elementary. Now, 6.3 is about volumes by cylindrical shells. Volume of a solid, shell method. The volume of a solid rotated about the y-axis, for example. We have some shape. You pick an increment, a thick slice of a rectangular shape, and you go around the y-axis, and you think about the shell method, okay? So you think about a cylindrical shape, the circumference times the height, if you will, that gives us the lateral surface. And if you multiply it by its thickness, it gives you the volume of this shell. So we have 2 pi x f of x dx. What is each part? 2 pi x is the circumference. How do you find the circumference of a cylindrical shape? The circumference is 2 pi r. Here's the circumference of the base. What is f of x? F of x is the height. What is dx is the thickness. So if you cut this open, or if you cut this open, never mind the top and the bottom. We are looking at the lateral surface. This is the lateral surface. 2 pi r. 2 pi r translates to 2 pi x. And then it has a small thickness, delta x. So 2 pi r or 2 pi x is the surface. When you multiply it by delta x, becomes the volume of that piece. And so dV, an increment of a volume, is 2 pi x or 2 pi r, f of x, h, dx, dr. So what I want you to notice, the way I like to use, instead of dx and dy, I'm going to go with dr, and I figure out whether I need dx or dy, because dr is the thickness. It's either dx or dy. As you can see here, this is the thickness dx. Okay, in this case, you're moving it along the x-axis. It has dx. So 2 pi r h dr. Let me clean up the mess. And so volume of a solid, shell method. The volume of a solid rotated by the x-axis is given by this 2 pi r. R is f of x or y, then f of y dy. Shell method. This is called the shell method because we use cylindrical shells after area of a moving cross section parallel to the axis of revolution. So either y f of y dy or x f of x dx. So with that being the case, let's look at this example. We want to find the volume of a solid obtained by rotating about the y-axis, the region bounded by this function, y equals 2x squared minus x cubed, and y equals 0. So first and foremost, you have to graph it. And you can use even a graphing calculator for that. So it looks like that. And remember, it's bounded by this, and y equals 0 is the x-axis. So we're talking about this region. This region. And we want to rotate this about the y-axis. So we pick an increment, a thick slice of a rectangular shape, and we rotate it about the y-axis. The method of shell, it creates this distance r equals x, the distance from the axis of rotation. The distance from the axis of rotation, r, is equal to x. So what is r? distance from axis of rotation. This is the R for this shell. This is the height, simply the y coordinate or f of x, which of course has the formula 2x squared minus x cubed in this case. All right. So R is x. The height is the y coordinate of this point, which is f of x or 2x squared minus x cubed. dr, the thickness, is dx. And I put dr, it just basically goes with that. Since this is x, is dx. And so let's put that into this formula, 2 pi r h dr. So 2 pi x times 2x squared minus x cubed. So I hope you see, again, the hardest part is to graph, figure out an increment of a volume, in this case using the shell, and then coming up with R, H, and dr. The rest becomes elementary. 2 pi, we can take it out. X and 2x squared is 2x cubed. X and minus x is minus x to the power 4. This gives you 2 over 4 or 1/2 x to the power 4. This gives you minus 1 over 5 x to the power 5. And we go, by the way, this happened to be 2. Okay, that's why we go from 0 to 2. This is 2. When you graph it, you can see it. Or all you have to do, if you set this one equal to 0, you get 0 and 2 here. Okay, set this. If you set it equal to 0, gives you 0 and 2. Okay, that's how we know those limits. Or just you look at the graph. All right, and so this is 2 pi. If you plug in 2 to the power of 4, 16 divided by 2 is 8. 2 to the power of 5 is 32 over 5. And then you do the math, you end up with 16 pi over 5, because 8 times 5, 40 minus 32 is 8 times 2 is 16. Find the volume of a solid obtained by rotating about the y-axis, the area under this function y equals x squared plus 1 over 0 and 6. Again, graphing is a must. Y equals x squared is a parabola, plus 1 shifts up by 1. So this is 1. Okay, this may not be to scale, or they scale along the x and y axis. They don't have to be the same. So 0 to 6 is here. Okay, just to give you an idea. Okay. Just for the sake of argument, at 6, we get 36 plus 1 over 37. Okay. And so we are looking at area under this curve over 0 and 6. So this area. Okay. So this is the area from 0 to 6, this shaded region. And when we revolve it about the y-axis, we're going to use the method of shell. So this is an increment that, by revolving about the y-axis, creates this shell. The distance from the axis of rotation, R, is x. The height, h, equals the y coordinate of this point, or f of x, which happened to be x squared plus 1. So, and the thickness is dx. So we write R is x, h is y or f of x, which is x squared plus 1. dr is dx. I'm looking at 2 pi r h dr. So I got the r, I got the h, and I got dr to be dx. If we plug in, we get 2 pi r is x, h is x squared plus 1, dr is dx. Again, I can put the 2 pi out. This is x cubed plus x. And if I want to integrate this again from 0 to 6, obviously it was mentioned. So this is 1/4 x to the power of 4 plus 1/2 x squared. 0 gives you 0. All you have to just plug in number 6. And you do the math. You end up with 684 pi. 684 pi. Find the volume of the solid revolution generated by rotating about the y-axis, the region bounded by the graph of y equals x squared, x equals 0, and y equals 4. And we're going to use actually two methods to compare and contrast. We had seen this before, so let's quickly graph the function of y equals x squared. X equals 0. Is the y-axis. Y equals 4, it's a horizontal line. And we're going to revolve this about the y-axis. So this is the region of interest. Okay, this is the region of interest. Again, y equals x squared. X equals 0 is this line, the y-axis, and y equals 4 is this line. So this is the region of interest. So we are going to move it this way around the y-axis. And the part that we have here, this one, for some reason, it's hard to see that. It creates the distance to the axis of revolution, r equals x. And from here, if you solve for x, x becomes square root of y. Remember, x is plus minus square root of y, and again, the right side would be positive square root of y. So when we rotate it about the y-axis, it generates this disk. This disk has this radius of x, the x coordinate, and it has this thickness. We are going to move this up and down. This thickness dh becomes dy, and this is r, which is the x coordinate of this point, which is square root of y. So dv, which is a times dh, is pi r squared dh, and r we established to be x, or square root of y, dy. So we're going to replace the x with square root of y, and we are going to integrate this from what? Well, we're going to go all the way to y equals 4. So from here to here, here to here. So from 0 to 4. So we're going to put this in here, integrate it from 0 to 4. Needless to say, this, when you square it, becomes y. We can keep the pi outside. Now the integration of that is simply 1/2 y squared. If you plug in 0, nothing happens. If you plug in 4, 4 squared is 16 divided by 2 is 8. 8 pi is the final answer using the disk method. Now, to use the shell method, 2 pi r HDR. Remember this 2 pi r HDR. We're going to use this. So we use this part, if you will. Now we are going to use the shell method. So the shell method is to create a shell by rotating about the y-axis, which is this shell. And so we have this height and we have this radius. The radius is x. So if you pick this point, the radius is x. The height at any given point is the top from the bottom. And it would be 4 minus x squared. This goes all the way here, if you will. This is r equals x. This is 4 minus x squared. 4 minus x squared. The top from the bottom. Okay. The 4 minus x squared. Therefore, r is x. H is 4 minus x squared. dr is dx, this thickness. So we plug in. And this will move along the x-axis. This point as coordinates 2, 4. So we did 0 to 4 with the disk, but now we're going to do 0 to 2 with the shell method. 0 to 2. So it's good to know this location. Now, of course, we can keep the 2 pi out. This is 4x minus x cubed. 4x results in 2x squared. This is minus 1/4 x squared. If you plug in 0, nothing happens. If you plug in 2 and do the math, 2 squared, 4 times 2 is 8. 2 to the power of 4, 16 divided by 4 is 4. So 8 minus 4, 4. 4 times 2 pi is 8 pi. And we get to the same answer.